This topic is called Basic Probability Theory, and this marks a change in direction for this course. The first few topics were all about mathematics and how that is applied to finance. This topic is the beginnings of the statistical part of the course. Now, in finance, we are regularly trying to make probability statements, or trying to look in, we're trying to look into the future. We're trying to work out what might happen in the future. We can't do that. Nobody can do that. Not with 100% certainty. The future is unknowable. What do? Well, we could just guess, but we can do a bit better than that. If we're standing in the present, the only thing that we've got to help us to look into the future is the past. So that's what we do. We look at what's happened in the past, we pick a period of time which we believe is relevant to what we're trying to look at into the future, and we call that the sample period. And we collect data on what has happened in the past based upon what we're interested in. We then look at that data and we analyse it carefully and look for patterns in the data. There's a whole range of different techniques that you'll learn about to do that. Some in this course, but in particular when you do financial econometrics, which is the next course leading on from this one. And that's really important because you'll learn about how to do those things. Once you've identified all of these things, then you can project those patterns into the future. And then based upon those patterns, you then are able to hopefully make probability statements about what might happen in the future. Classic example, what's going to happen to the exchange rate tomorrow? Well, what do? We go through and we say that the last 20 days, the exchange rate, the Australian dollar, appreciated 15 times. All right? It depreciated 5 times. If that's what we're going to do, if we're going to adopt what's known as the relative frequency approach to probabilities, then what we do is we say that there is a 75% chance the exchange rate will go up tomorrow. May or may not happen, we don't know. But that's the sort of idea of what we're doing. Now that's obviously very simple, and we'll have more complicated methods to do that sort of thing as well. Okay, so that's the idea. Now obviously to do that sort of thing, you've got to know a fair bit about probability. Now, if you look through the lecture notes, you'll see that there's a whole lot of things about what are called axioms or basic rules for probability, and so you need to know about those, and so you need to read how they work. These are things that many of you will have done in high school, but just reminding you of how they work. Now, one of the other things that's really important, and if you have a look in the lecture notes, there's a nice article and it's called Getting the Goat. Now, I'd encourage you, it's only a page and a half to read, so it's not too hard to read. So I'd like you to have a read of it. And what it actually says is it starts off, it's out of The Economist magazine, it starts off and it says, never trust your guesses. And what it's got is a whole series of little conundrums where you might ask someone, what do you think is going to happen based upon this whole range of different things? And then people have a guess, and then you go through and work out the answer using probability rules, and you find that your guesses are almost all, well in these examples in particular, are very different to the reality. Getting the Goat, it's a game show where if you guessed what was in a box, if you guessed right, you got a car, if you guessed wrong, you got a goat. It's a bit hard to explain quickly now, so have a read of it. Another one that I really like is if you're sitting in a room with 25 people and you say, what's the chances of there being 2 people with the same birthday in that room? Nearly everybody, when they're asked that question, says, oh, it's not very high at all, because they know when their birthday is. But then they think, what's the chance of this person having the same birthday? 1 in 365, etc., etc. It's very low. But it doesn't have to be your birthday. And in fact, if you go through the maths, and it's explained in those notes, it's about 60%. That is, 6 times out of 10 you do that exercise, you're going to find that 2 people have the same birthday. Although it assumes that, of course, that probability is assuming that birthdays are completely randomly distributed, which they're not quite. Birthdays throughout the year depend upon fertility and things like that. In Australia, the highest birth month is September, which probably has something to do with New Year's Eve, I think, something like that. Anyway, that's not directly relevant. What I'm trying to do is you read that article, the idea is that it's trying to motivate you to understand a bit about probability, and then when you go through and you do that, you'll see why it is so important that you understand these rules, and you'll need to go through that. Now, there are 2 broad parts of this lecture. or this topic. One is just looking at the basic rules, and the next one is looking at what's known as univariate probability distributions. Now, a univariate probability distribution means that you are just looking at one variable. And so in the example, it's a simple little example where you're looking at the returns on a particular stock, that is a share, and we're saying, you know, there's a certain percent, in the past, the returns were 20% this many times, 15% this many times, 10% this many times, 5% this many times, and then we have attached probabilities to all of those returns, and then we spend a lot of time then trying to work out what is likely to happen in the future based upon this. Now, if you just look at that, and this is a completely hypothetical example, just looking at those numbers, when you look at them in the notes, you'll see it's really hard to work out what's going to happen by just looking at those numbers. So what actually you do is we calculate what are known as descriptive statistics for this distribution. Now, the descriptive statistics are measures of central tendency, are things that's a single number to represent the entire distribution, mean, median, mode, so arithmetic and geometric mean, these sorts of things, and that gives you a single number, and that's the average return. Then we look at measures of dispersion, how spread out it is or not. Now, dispersion is really important because that tells us, in finance, that tells us about riskiness. Okay, if it's highly dispersed, it's a risky stock. If it's narrowly dispersed, it's a less risky stock. And the measures that are used that as the range, the biggest minus the smallest, the variance and the standard deviation. We also look at the skewness of the distribution, and that's the issue of whether it's a symmetrical distribution or if it's positively or negatively skewed. Skewness is a very interesting concept because it tells us it's to do with the shape. And we also look at something called the kurtosis of the distribution. Now, the kurtosis is actually used to try and see how close the distribution is to being a normal distribution, and the normal distribution is a theoretical probability distribution that we use continually throughout this course. So that's the idea of this probability topic. Firstly, motivate you to understand why it's so important to understand some probabilities, and then spend some time learning about calculating the descriptive statistics for a univariate probability distribution, because then we can use those descriptive statistics to assist us to make judgments as to what might happen in the future with this particular thing. And the example here is a share, and that's obviously a really important thing in terms of finance. Thank you.